right, it's 7 a.m. Thank you everyone for being here. Today we're going to go over furnace diagnostics, kind of a not too deep of a dive. I want to make sure you guys just kind of understand the basics of where to start, where to look for stuff, where you're going to find the information you need. My name's Mike. I work for Gensco. I'm a field service rep for Training America Standard Products. And let's get in. Let's go. We're going to go over what tools you need. Simply put, basic diagnostic tools you're going to need for checking these, all the things we're going to go about over. Where do we find the data? So nothing I'm going to tell you is something that's coming out of my brain. It's coming out of service facts, installation instructions. This is all documentation. I'm going to show you where to find it because not every single piece of equipment is identical. And then when we do find the data, how do we test what we, to find the result we're looking for? We got something that's not working. How do we test it to verify if it's the problem, if there's something else going on? Simply put, we're not going to need a lot of tools. You're going to need a multimeter. There's no wrong brand, but you're going to want a multimeter that can check amps, that can check AC voltage, DC voltage. I'm going to want to make sure you have the right leads. And by the right leads, I'm talking about things like this. You have those micro leads, the needle leads that are really fine tip points. Those help us get into the back of plugs, which is very helpful when doing a diagnostic when you are not sure if we have the right voltage somewhere, where you don't need to take the plug off to test it. Testing it live is very useful. Your standard meter leads are going to be helpful for some of the stuff you're going to be testing. I'm not going to say don't use these because there's a lot of times where those standard leads are just fine. And I really do like the alligator clip leads. This is all part of one pack you can go buy. Gensco carries them. It comes with all three of these. The alligator clips are great when you're trying to test from ground or common to a bunch of different points. You don't have to hold that ground or common on there. You can just clip it on, and then you can go around and check all the different points around the unit you're working on. Makes it really handy, really helpful, frees up a hand. You're also going to need a manometer. Do you require to use a dual port? No, I find them more useful. You can use them for everything. You can use a single port manometer plus other things. So a manometer of some type would be very fantastic. You're going to need it to check gas pressures, static pressures, pressures to your pressure switches, all this kind of stuff. It's very, very, very helpful. We're going to need that. And like I said, where do we find this service data? All this information we're going to be going over. Everything I'm going to show you is going to be coming right out of the IOM, the Installation, Operation, and Maintenance Manuals, or the service facts. Some units have combined the service facts into the installation instructions, and they're going to label it the IOM, the Installation, Operation, and Maintenance. Some are going to have the installation instructions and the service facts separate. So please understand that depending on the model of your equipment is going to depend on where we're going to find this information. And one thing we're looking for, and this is usually printed on the inside of the door of the equipment you're working on, but it's not always there. This can also always be found in your IOMs or in your service facts. The air codes. So we're looking here at some of the older air codes off your legacy 40-inch furnaces, right? The XV95s, the XR90s, all that kind of stuff, right? You're going to have a list of air codes. Sometimes as little as 5 air codes up to like 9, right? So we're going to see here there is no one flash. In this case, a one flash is just normal, right? No call for heat or a call for heat. So if you get a single one flash, that's not a problem. One red flash is not necessarily a problem. But you look here, we get the 2 flash, 3 flash, 4, 5, 6, 7, 8, 9. If you look, these are 2 different furnaces, but they're given a lot of the same air codes, right? 2 flash is always retries, recycles, which means we failed the light. A 3 flash, pressure switch error. Not necessarily pressure switch, does say inducer or pressure switch error, but pressure switch error. 3 flash, a temperature limit of some type, whether that is, it's just, on this one, it's just any open limit. Here it could be a open limit or a rollout, right? 5 flash, we're getting into flame sense when there should not be present. In other words, our flame sensor is probably shorted or grounded. 6 flash, polarity issue. So is our high voltage correct? 7 flash, gas valve circuit error. This is very confusing to a lot of people. They always go and replace the gas valve. The gas valve circuit error could be referring to that, but more typically speaking, it's referring to the relay on the board, not the valve itself. 8 flash, weak flame, low flame sense. I'll show you today how to measure that. And then 9 flash would be an inducer limit error or an igniter error, right? It depends on the model. This 9 flash is not always the same. Then we get into a little bit more current models. Here's our S8X or S9X. They're going to have a lot more errors. This is our constant torque motors. You're going to see we have some new errors on here that we didn't have before, or some more, how to put this, more dissected, kind of. They're going to break the same error up into multiple different options here. So the 1 flash here, EO1, it's not a flash anymore. We got a 7-segment display. We're talking about the board just failed. It's got an internal failure. It's identified that it's something internal to the circuit board has failed. You're done diagnosing. If it's got a EO1, you're replacing the board. Pretty simple. But then we get our 2 flash. Our 2 flash becomes an E201, 202.2, 2.3, and it's going to be more specific. These boards have more ways to read and interpret the information, and they're going to be more direct. So as you see here, retries exceeded, which means flame was never sent. So it never saw the flame sensor. We'll go over some of that. Here is retries, recycles exceeded. So it did light, it did see the flame, and then we lost it. Why are we losing our flame? And then 2.3, gas valve energized when it should not be energized. So that's a very different thing there, right? So they're more specific. They've broken it down. They've got more information to help you understand it more quickly. The three flash errors, we've got 4 of them: a 3.1, 3.2, 3.3, 3.4 on both these, right? It's telling you more specifically which pressure switch. Is it open when it should be closed? Is it closed when it should be open? Is it pressure switch 1? Is it pressure switch 2? So we've got any of those combinations, you've got its own specific error now, which just gets you to the answer more quickly. So you're not trying to check things that you don't need to check. EO4, thermal limit, right? You'll find when we get to the next version, there's even more of those. There's just any of the open limits, any of them. They're all in series on some of these. 5 flash, still, flame detected when it should not be. So that's really the same as we were on our older furnaces, right? That hasn't changed. 6.1, 6.2, 6.3. Before that was all into 1, which was just polarity issue. Now we got into grounding issues or igniter relays. We're looking at all that, and it's breaking it down for you there. 7, gas valve energized when it should not be. It's the same as it was before. 8, flame current low. Same as it was on the previous models, right? Low flame sense. And now here we don't even have an E9. We go to E11, E12, which are some blower and some fuse options. Here we do have an E9. This is going to be different now than our previous versions. We have this, one of our most common error codes we'd see is the E09. It's pressure switch that is connected to your condensate, to your drain. So if your drain is backed up, it will trip a condensate switch, which will turn off the furnace. Then we get into some E11s, E12s, again, more detailed stuff here than we were before, new error codes. When you get really deep into it, now we're going to the S9 V2, S8 V2, S8 on the left, S9 on the right, a whole bunch more errors. We'll keep on adding. We're up to 18 or even 28 on the S8 V2. There's a lot going on. It's not to confuse you. We're giving you more errors to help you get to the answer more quickly, right? Instead of having just 5 or 6 or 9 flat, errors, we're having up to E28, right? I mean, we're having a lot of error codes to help direct you directly to the problem more quickly. So when you get these error codes, if you turn the door around and look at the inside of the door, you're going to have a list that looks just like this, or just like this. It's going to look like the screen, right? It's going to have all these explanations. And the nice thing is, in the back of the service facts or the IOM, it'll even have a flow chart to walk you through testing each of these error codes. Every single error code's got a flow chart. I'll be honest, the EO1 is one of my favorites because internal failure. It just says replace the IFC, replace your control board. One of the easiest ones out there. I like that one. Some of them are going to have multiple steps. Sometimes they're like 10, 12 steps to kind of testing everything because there's more than one thing that can be wrong to cause that error. And so they're going to walk you through it, break it down step by step. What do you need to do to find out what's wrong? Make sure we're not just replacing parts at it. No one out there, at least I hope no one out there wants to be part of just a parts hanger, just hang up parts until it fixes it. That's embarrassing for you. It's embarrassing in front of the homeowner. Um, and I'll be honest, a lot of times if you're trying to warranty out 3, 4 different parts at once, it'll get denied by the factory because they know you're just hanging parts. You're not actually diagnosing the problem. So the most common errors we're going to see are the first ones, right? The 2 flash, 3 flash, the 4 flash, our retries, which are, we're going to dig deeper into the 3 flash, our pressure switch, our 4 flash, our limits. For some reason, we get calls on a lot of these, and I understand some of them why we're getting calls on them, but if you just kind of look at it, step back and don't just focus on the problem, what it's identifying. Like if it said bad pressure switch, it's not a bad pressure switch. It's most likely something else. Same thing with the retries. It's not lighting. Oh, great. Is the igniter actually glowing? Is it getting hot? Maybe it is. And so we're gonna go through some of this and talk about how to dig a little deeper. So if we are getting a 2 flash or an EO2, there's so many things to look at here. The most common thing people do is they say, well, I replaced the flame sensor and it still won't light. Well, okay, was it the flame sensor? Flame sensor is one of the best places to start. I'm going to want to take that flame sensor out, examine it, make sure it's clean, not a lot of buildup on it. I want to make sure that the porcelain on there is not cracked or damaged. If the steel hole in there will spin inside the porcelain, if you can spin it 360, that's a problem. It should be firmly in place inside there. So if it's spinning, that's a sign that we have damaged porcelain and it's broken, and I would want to replace it. Understanding how the ignition circuit works, we are sending a little bit of voltage off the board, and we are sending that to use the flame as a jumper to jump to ground. And it needs to land on ground. How does it get to ground? It goes through the burners. So if we have a lot of dirty buildup on the flame sensor, I can guarantee you have the same dirty buildup on the burners. And if it can inhibit the flame sensor, it can inhibit the burners as well. I'll be honest, my own furnace. I cleaned the flame sensor, but I was in a hurry, so I didn't clean the burners, and guess what? It shut down on me on an EO2. You need to clean the burners. If you're cleaning the flame sensor, you need to remove and clean the burners. They do get some buildup on them. The other parts that can happen, I mean, it's just saying it doesn't know why it didn't light, right? So we could have an igniter problem. Is our igniter working? Is it glowing? Is it getting hot? Is it getting hot enough? Also, we could have an igniter getting hot. We could have clean burners and flame sensor, but if that gas valve is not opening, that's going to give you an EO2 as well. I talk about a plugged orifice on here. There are times where, in my own experience, where I've come across, it doesn't really get buildup or dirty on the orifice, but I have found spiders, specifically a yellow sac spider, they like to crawl inside there, and they will build a very tight little nest, and they will plug your orifice. Be careful when you're removing. You're going to unscrew those orifices and have to. I've actually had one in my hand, and I saw there was a white mesh in there, and I went to scrape that white mesh out, and a spider crawled out onto my hand. It was a little bit of a surprise, I'll say that. But you can get these little yellow sac spiders, especially right now, this time of year in the fall, when people haven't been running their furnace all winter, and they will jump in there, build a little nest, and they just use it to sleep. They don't go and try and catch bugs and eat them there. They are using it just as a little nest. So it's a really, really tight, solid weave. It's not a web like you're used to. It's almost like a piece of silk fabric. It's very tight and it can block the flow of gas through that orifice. So if you're getting a hot igniter and you can hear the gas flowing, but it's not lighting at that first burner where the igniter is, we could have a plugged orifice. It's an odd thing, and I've seen people replace igniters and flame sensors, and and even gas valves, all because you had a spider get in there and build a little nest. And they can build it literally overnight. Like in one day, they build that nest. So it's not like something that takes that they're going to set up shop there for a month. Um, another thing that can go wrong here, like I talked about back at the first part there, we're trying to send voltage through the flame sensor to the burners to get to ground. So if our ground is not proper, we don't have a proper ground, you're going to get a 2 flash. You're going to get an EO2. If for whatever reason something happened in the house, we lost our ground to that furnace, EO2, I promise you. So we want to make sure we have a good ground. I've come behind people where they did a maintenance, pulled the ground wire off because the only way to remove the burners and get in there and clean everything was to pull the manifold off, and the ground wire screws down right there to the corner of the manifold. And when they put it all back together, they forgot to reattach the ground wire. And then they left. They didn't test it when they were done, and EO2. Okay. And the last thing that can always happen is we could have a board failure. I didn't put it on there, but it's one of those things where, yeah, you could have a board that's just not sending the voltage out. We're going to talk about how to test that, which kind of works in the board into that. So there's a couple ways you can measure flame current. Some of our boards, you'll see they have this little part right here. It'll have a little box. It'll have 2 little solder points. It'll say FP. So flame proving is what we're looking at. And so what you can do with your meter, you don't need the needle leads, just your regular leads will work. Set it to volts DC. Set your voltmeter to volts DC, and you can measure from these 2 points, put 1 lead to each of those 2 points, and when the flames light, you will see what that flame sensor is reading. For every 1 volt DC, you're getting 1 microamp, which we're looking for around 0.75 to 3 microamps, so about 0.75 to 3 volts DC. If you're reading at 0.8, you are right on the limit. You're really low, right? I want to see something much higher than that. In the twos would be great. But that's going to show you how dirty your flame sensor is, how dirty your burners are, and kind of how good your ground is, right? Because we want to see upwards of 3 microamps or 3 volts DC at those 2 little solder points. Now, not every single one of our furnaces have them, but a good chunk of our new S model furnaces do have that test spot on the board. The old-fashioned way, if you don't have those test spots, is you have to have a meter, set it to DC microamps. Not every meter has that, but if you do, you can set it to DC microamps, and you're going to connect your meter in series with the flame sensor. So this wire right here on the right normally would be the one that plugs into the flame sensor. So you're going to unplug it from the flame sensor, and you're going to set it up so that the voltage has to travel through your meter to get to the flame sensor. You will be reading the same microamps at 0.75 to 3. It's not every meter has that capacity. And if your meter does, this is the preferred method of testing it. Okay, this is going to work really well. If you don't have that on your meter, you're going to be testing on this little FP. If it doesn't have this FP and you don't have a meter that can do it, I recommend you upgrade your meter to a meter that has more capacity, more capabilities. And by the way, if you guys have questions at any point, just throw them up in chat. I am watching chat, so we can answer your questions live. That way we're not falling behind. 3 flash. Our inducer, our pressure switch faults. So typically speaking, people get a 3 flash. One of the first things they do is they replace that pressure switch. I hate that. People that replace parts without testing them. Because do pressure switches ever fail? Yes, they do. Typically it's because they get water in them, something like that. And once you get that water in there, it is really difficult to ever get it out. That being said, pressure switches are probably the least common problem when you get a 3 flash. Typically speaking, it's something else. So what could be happening here? We could get some water. It is possible. Water in the hose, water in the pressure switch itself. Definitely a possibility. So one of the first things I like to do is take the hose off the back of the pressure switch and blow it out into my hand or onto a towel. See, do I get a drop of water? If you get some water, not a good sign. That's indicative of we have something else going on. We could have an inducer that's not draining properly, backing up water into the system, right? If it's got a clogged drain, I have found, and I'm sure you've all found lots of reasons that it does not drain properly. And you can hear it splashing around, typically speaking. If that inducer is trying to push water, it's not designed to do that. It's designed to push air. And so if it's trying to push water, it can't spin at the right speed, so it can't close the pressure switch. So another thing, restriction in our flue pipes, right? This sounds just seems so simple, but so many people neglect to just verify. I mean, how much air am I moving? And so you're gonna have to check. I mean, are we getting the proper airflow to the pressure switch, right? Is it, if it's a positive pressure, are we getting enough positive pressure on it? It's negative pressure. Is it sucking hard enough, right? Are we moving the right air through our vent system? Uh, if you're not, I mean, there's only a couple things that's going to cause it not to move enough air. One is the motor's not running the right speed, or two, there's a restriction. Period. That's it. There's not much else to it. Um, this can happen where we have pressure switches that are not configured for the orientation of the furnace. Excuse me. A lot of times our furnaces have multi-positions they can run in. Some, like our upflows can be horizontal left, horizontal right, or upflow. Our downflows can only be downflow. That being said, our draft motors can come out the top or out the left. And so as you're rotating the furnace, or you're rotating the draft motor, a lot of times those pressure switches are attached to it, or they need to be rotated as well. Please confirm with the installation instructions that it is configured and set up correctly. Our hoses that go to our pressure switches and to our drains sometimes need to be shortened. They come with the maximum tube length that is required for every application. And sometimes when you are not configuring at all, you're leaving it in the original position, you need to shorten some of those tubes because they are shipped with a hose that's long enough for a different position. Another thing that can have a problem here is improper voltage. What I'm talking about here is our pressure switches are just checking 24 volts through them, right? They're passing 24 volts through. When they're open, 0 volts go through. When they're closed, 24 volts go through. I have found that sometimes we have a slight restriction in our pressure switch. I'm not talking about the air side, I'm talking about the voltage side, where it only sends 12 volts through it. You got 24 volts coming in, 12 volts coming out the other side, right? We have a bad switch. It's like a pitted contactor, same kind of idea. Right? We're not sending the right voltage through. So how do we test some of this stuff? Well, the first thing I recommend anyone does when you are getting a pressure switch, a 3-flash air, is get out your manometer and check what kind of pressure we are getting to that switch. Because if it's not achieving the right pressure, then it's not going to close. It has nothing to do with the pressure switch. It has everything to do with the other parts of the system, the draft motor, the venting, everything else. So first thing you should always do is bust out your manometer. Let's check that the static pressure we're getting to it. Okay. Next thing you want to do is, okay, are we getting the voltage to our pressure switch? Depending on the unit, sometimes your voltage is going to go through a multitude of different devices before it gets to the pressure switch. And once it leaves the pressure switch, is it making it back to the board? We'll look at some schematics here in a little bit, but make sure we are getting the voltage to the pressure switch and out of it. If we're not getting the right voltage, it ain't going to work. It ain't going to run. So next, I mean, if we're not getting the right static pressure, let's check for obstructions in your flue. What are you going to find? Your flue is on our 90%ers, typically it's 2-pipe. You're going to have an intake and an exhaust. On our 80%ers, you just have an exhaust. We get a lot less pressure switch airs on our 80%ers because just the way they're designed, right? We have more sealed up kind of less ability for get obstructions, but it does happen. I found bees nests in your high wind caps that are blocking your flue. I found mud wasps in a 90% exhaust about 8 feet into the pipe around a corner. So bees, wasps, they will build nests in there if they are given the opportunity. It's a nice, safe place for them to build a nest. Birds and stuff can't get to them. They love it. I've actually found birds I'm sure some of you maybe have found birds. They make it all the way back to the draft motor and build a nest in there in the summertime. And then the wintertime comes along and turn it on and boom, we got dead birds in there. Typically speaking, the mama bird can get in and out, but the babies cannot. I had people call me and they've had as much odd things as uh, what do you call it? Teflon tape rolls. People have dropped down there. Vent, what do you call those things? Gas pipe 90s have been in the flue pipes. Lots of stuff can be in the flues to obstruct it. And so if you're not sure, you're going to need to maybe take a manometer out and check your pressure at the furnace and then down the line. You might have to drill a hole in your pipe. Check that out. Um, when I found the bee's nest, the wasp nest, I pulled off the flue at the furnace and felt how hard it was blowing. Then I went outside. It was a horizontal venting. Put my hand at the vent outside. Could barely feel any air coming out. It was a good sign that's an obstruction there, right? So just because the fan's running doesn't mean the pipes are clear. Your intake can get all kinds of stuff. There's usually a screen right as it enters the furnace. That screen, I've seen it plugged with leaves, bees, bugs, all kinds of material. So make sure your flue pipes, both your intake and your exhaust, are clear. And then check your drain. Make sure it's running clear, because if that draft motor is trying to move water, it's going to have an issue. So if it turns on and runs, and then after about 5 minutes of runtime, we're shutting off because it's opening the pressure switch, to me, that delayed reaction is a big sign that our drain is backing up into the fan. So why is our drain backing up? Is it double trapped? Do we have something clogging it? Lots of stuff can go on. Temperature limits. So we have lots of limits. I'm going to look at those in the next couple slides. But if you're tripping a EO4, if you got a 4 flash, comes down to two things 99% of the time. We have low airflow, or we have too much gas pressure. But really, it's too low of airflow almost every time, or we're tripping a limit. So do we have a dirty filter? Do we have closed vents? Do we have, I've seen all that, right? Closed registers can cause this. I've seen someone put their dog's kennel right in front of the return arrow, the sidewall return. There's a big old St. Bernard, and when he laid against that return, he blocked the airflow and it shut down the furnace because it would overheat. Dog liked it because it was nice cool air blowing across him. It was a big dog. So airflow is a good idea to verify your gas pressure. I have seen, especially with our LP conversions, they don't get converted correctly and we have the wrong gas pressure. And the last thing is, you know what? Sometimes we just have a wire that came off of I've seen wires hanging off of connections where they should be, and that is all the problem is. So check your voltage going out and back. Let's look at how you do that. So right here on the left is a schematic. Try not to focus too much on that. Right, here's a pictorial schematic. We went over these a couple of months back, and the ladder schematic. The ladders really make it a lot easier. Here's a zoom in part here, and let's take a look at this a little bit closer still. If you look at here, it says HLO. Now each furnace is gonna be a little bit different. This is an S8 V2, I believe. Power comes out, high limit out. So if I follow this red wire, it comes down here to this little node where it splits, and it goes to multiple things. The first thing it goes to, it comes this RAF2, comes out of that and goes into the RAF1, and it comes back to the board on RAF. Well, what's RAF? RAF is reverse airflow. And on all of our furnaces, downflow, upflow, they all have at least one, if not two, reverse airflow limits. These limits are in the blower compartment. And if there's two of them, there's one on each side of the blower, one on the left, one on the right. Because if you put it in a horizontal application, horizontal left or horizontal right, we want to have one of these on top of the blower. When it's on its side, it'll be either the left or right side, then the opposite side will be on top, right? So we have two of these on all of our upflows. Our downflows might only have one because it's only got one position it can be in, the downflow position. And so it's still gonna have a reverse airflow in case that fan stops. That heat's gonna go back through the fan. It's gonna trip a limit. Reverse airflow. Okay. Reverse airflow means our fan's not working. So we can just measure that on pin 2, HLO, and then measure that. Where does that come back? Right there, RAF, pin 8. So if I measure from common to pin 8, the yellow wire coming in here, and I see 24 volts, well, then I know that those reverse airflow limits are closed, and they're good. If I see 0 volts on pin 8, but I have 24 volts on pin 2, that tells me that my reverse airflow limits are open. I don't need to get into the blower compartment to see they're open. I can measure it at the board if I'm just paying attention and using the schematic. Now on this node here, that means the wire is splitting, it's going 2 different directions. It also comes down here and goes to our flame rollout 2 and our flame rollout 1. It comes back. There should be another node right there, and it comes up and it lands on RLI. Rollout limit in. So yes, you can go measure the voltage at your rollouts. I'm not going to say it's a bad idea. It'll work. It's not that difficult to get to, but sometimes they're on the side of the burner, and to get to them, it is awkward because on a smaller furnace, there's not a lot of room there. Great. Just measure it at the board. RLI. Boom. And if you have 24 volts there, you know those are closed. If you have 0 volts there, you know that one of them's open. You can dig deeper. But at this node, that voltage goes through your rollouts, then it comes back to this node, and it comes down here again and goes to your main high thermal limit, and it comes back to the board on HLI, high limit in. So if you have 24 volts on the rollout, the RAF, but it's 0 volts on the HLI, you can tell, beyond a shadow of a doubt, that limit's open. So there you go. Also, with all your limits, when you're ohming them, if you're going to take the power off of them and you're going to ohm them when they're not connected and not plugged in and not turned on, you're going to want to have less than 1 ohm resistance there. I have found some people that have had around like 8, 10, 12 ohms resistance through a limit, and you'll see voltage on the other side. Problem is you can't do any work. There's not enough amperage left over to open a gas valve. So voltage can be misleading sometimes. Just FYI. It's rare, but it does happen. You also see our pressure switches here, right? Pressure PSO, pressure switch out. Power comes into these. You notice it splits at that node, goes into both pressure switches, 1 and 2. And as they individually close, they'll send 24 volts back to the board. PS1, PS2. I like it that they're colored. So in this case, they're orange and brown on these 2 pressure switches. As we have more items there, they're going to have their own colors. You can just follow that wire back into the board, check for that color. It makes it really easy to see where you're at. Easiest way to check your limits. You got an EO4, check. Am I getting 24 volts out of the board? Because if you're not getting 24 volts out of the board, you got a board problem. It's not a limit problem. You got a board problem. And if you are getting 24 volts out, am I getting 24 volts back on each of the limits? If you're not, and typically speaking, this is reverse airflow. We had a dirty filter. We had a motor problem. Something like that happened, and now we have a trip limit that didn't reset for whatever reason. Typically speaking, everyone knows where the rollouts are. Everyone knows where your main high limit is. They've checked, they say, I checked both my limits and I still am getting the EO4. I'm like, well, did you check your reverse airflow? Where's that? If they're on the blower. That being said, it's a lot easier to just check it at the board than it is to check it at the limit itself, because you have to pull the panel off to get to the blower. Sometimes you got to pull the blower out to get full access to it. Not always the most convenient limit to get to, but it has to be where it's at for the purpose that it's serving. But if you pay attention to your schematic, you can see how to follow the wires there. So there's a few other troubleshooting things we run across. These are our other, depending on the situation, things we're seeing a lot of. We see polarity issues, grounding issues. So I'm going to show you a really easy way to check those. Igniter testing. People call all the time and if you guys are sitting at a computer and if you're going to take a screenshot of something, I'm going to show you something here coming up very shortly you want to take a screenshot of. And then our blower testing. The nice thing about testing our blowers is there's a way to test all of our blowers, and I'm going to walk you through all 3 of them, okay? Polarity issues. This is how I check polarity. This is how I check my ground. A lot of people say, my ground's good. Oh yeah, how do you know it's good? And I hate the word good when you're describing voltage, airflow, refrigerant pressures. Good is not a number. It's a 4-letter word. It's not a number. So please don't ever tell me it's good. It's not going to go well because I'm going to force you to test it. But here's how I test for a ground, right? If you look at in a panel, if you look where the ground goes, it lands on a bus bar. So does the neutral. They're connected in one way or another, right? So what I want to check is, what is my line voltage to neutral? It should be roughly, 120, but it's never going to be 120. It's be 119, 122, something like that, right? Then I'm going to check my line voltage to ground. Okay. This should be the same. Every time I ask people to do this, about half the time, well, I ask everyone to check this. As I say every time, and because I want to know what are these 3 numbers, and people get a little bit frustrated. They think it's simple checks, simple things. They don't need to check it, but neutral to ground, or sorry, line to neutral, line to ground, those should match each other. About half the time when I ask people to get and to check this, and they're having, a E6, a polarity or grounding issue, these numbers don't match. And then I have them check from neutral to ground, and they'll see 19 volts there. What does that tell me? That tells me that our ground is not grounded. They'll say, well, that doesn't make sense. I can see it. It's tied in right here at the furnace, which is great. I'm glad they tied it in the furnace. But what that's telling me is when it leaves that junction box of the furnace, it does not go back to the panel. It might go back to another junction box where it just ties into the conduit. The conduit is not always grounded, especially in a lot of older houses. We want to make sure we have a good ground that is going all the way back to the panel. If you don't, especially on these newer furnaces, they're going to have issues, period. They'll say, well, the last furnace didn't have an issue. I'm like, well, the last furnace was from 1976, they made them a little bit differently back then. They didn't have the complicated circuit boards that we do now that require a proper ground. They didn't have flame sensors, right? So they had a standing pilot with a thermocouple. So it is very important. If you've never done it this way, I recommend this. This is simple. It takes 3 tests: line to neutral, line to ground, neutral to ground. You can test all that inside your furnace, and I recommend you do it inside the furnace. So I want to make sure it's getting there. This is our igniters, right? Our igniters, always when you're ohming an igniter, don't do it right after it lit. You want it cold. I would, it's got to be turned off for a while to the point where we're not still hot, right? You're going to ohm it cold. So ideally, it's before you get started, you unplug it and ohm it. You don't need to remove it from the furnace. You can just unplug the plug and ohm that thing. If it's an 80-volt igniter, we're going to typically be between 11 and 17 ohms. If it's a 120 volt, it's going to be between 37 and 70, okay? Here's the next one I'm going to show you the next page. This one you want to screenshot if you're going to screenshot. It's kind of got all of our igniters on it. I like it. Depending on what style you got, our ohm values. So some of them are going to be a little bit different. So just, this is where we're looking, okay? Like on our O54s, our silicon nitride 120 volt igniters, I'm looking to have under 100 ohms, okay? All of our 80 volt igniters, I want between 11 and 17. So yeah, the silicon nitride versus silicon carbide, a little bit different. You guys know what I'm talking about when you see these. So those are your ohm readings. If you are outside of that range, that's a great time to talk to your homeowners about, hey, your igniter hasn't failed yet, but it's about to. If you're there for a maintenance, that's a great time to recommend replacing that igniter before it fails. That's the whole point of a maintenance, is to catch this stuff before it fails, right? So there you go. And if you have that screenshot, this is directly from the manufacturer. So you can say, this is what the manufacturer recommends. If it's outside of this range, it should be replaced. Pretty simple, right? Our blower testing. So we have some go, no go tests for our blowers. We have 3 major types that are go, no go tests. We have the 16-pin variable speed blowers. You're going to find on some of our older furnaces, but also some of our current models, like a TEM6 is going to have this in there. So will the old 4 TEEs and all of our like XV95, some of our older products that have the 16-pin blowers. If you're wondering what I'm talking about, it's going to have a plug like this go into the motor. Okay. Very simple test. First things first, verify, do I have my 120 volts? Because we're talking about furnaces here, but air handlers would be 240, 220, right? Do I have my 115, 120 volts going to the motor? FYI, we should have high voltage at all of our variable speed motors all the time. 120 volts going to that motor as soon as that furnace powers up every time. If you verified that first, we can now unplug the plug from the board, and you are going to take 24 volts and common, and you're going to plug it into this plug as shown here in the picture, and you are then going to power up the furnace. So it's already, we know it's got 120. You're going to send 24 volts in common on these 4 pins. Pins 12 and 15 for 24 volts and 1 and 3 for common. If you do that, that motor is going to run at, I think, 50% fan speed, or the 75. I get it. It's going to run the fan. The fan should run. If the fan does not run, then you've got a bad motor. If the fan does run, that's indicative that we have a board that is not sending the proper voltage, because the fan seems to run when it gets a signal. So it's a go, no go test. If you do this, that 16-pin fan should run, period. When you are making these connections here, please have the power off the furnace and then power it up once everything's ready. So, and typically speaking, I'm going to pull these 24 volts in common right off the R and C on the board. So take 2 pieces, 4 pieces of stat wire, run 2 of them to R, 2 of them to common, and then shove the other ends into that plug. Next, we have our constant torque motors. So our constant torque motors are all of our X models, S8X1, S8X2, S9X, all of our X model furnaces. They're going to have this 6-pin constant torque motor connection. We're still going to have 120 volts go into that motor at all times. You're going to measure that up here on the top of the board on neutral and line voltage. Verify that we have 120 volts going to that motor. If we do, great. Let's send it a signal. So where do you find that? On the side of the board here, going to have a 6-pin plug. Kind of hard to see, but you got on the bottom is ground, aka common. And then you're going to have tap 1, 2, 3, 4, and 5. If you wanted to, while it's plugged in, when that fan turns on, it should display on the board TP1, TP2, TP3, whatever, tap TP9, whatever speed tap it's supposed to be running at. And while it's running, or while it's energized, you should read the DC voltage listed here. So tap 1 through 5, you're going to get either 8 or 18 volts DC to any of these 5 speed taps. Tap 6 through 9, you're going to get 8 volts DC to tap 1, plus either 8 or 18 volts to tap 2, 3, 4, and 5. So you have a combination. That's how we get 9 taps. So pretty simple. You're either getting voltage to the motor or you're not. So you can, if you're going to need your needle leads for that, your micro leads, because if you don't have those, you're not going to fit in the back of the plug, period. But for the go, no go test, quite simply, you're going to unplug that plug from the board, and you are going to put common wire into the blue marked ground. You're going to put common into that tap, and you're going to put 24 volts off the board into any of the other 5 speed taps. Doesn't matter which one. You can do it one at a time to each, but I do recommend you turn the power off before putting that wire into each of those speed taps. I don't want to see it arcing. That's bad. Yeah, at the end of the thing, I can put that 16-pin back up there on the board for you. I saw that. Someone asked if we can put that picture of the 16-pin back up. Some people want to screenshot it. I think that's a great idea. So for any of these constant torque motors, please, it's really simple. You need 2 wires, red and common, 24 volts in common. That's it. Common goes to blue, 24 volts goes to any of the speed taps that are not working. Now, I have seen where someone says it doesn't run I look at it and it says it's running on TP3 and the fan does not run. We put 24 volts TP3 to tap 3 and it does not run. But we put 24 volts to tap 1 and the fan runs. Tap 2, the fan runs. Tap 4, the fan runs. Tap 5, the fan runs. And so you can have a dead tap. And if you do, that's a big sign that we have a bad motor. And you can test that very quickly, which is putting 24 volts to it. So make sure when you're doing this, though, that it is not attached to the board anymore. We want to just be, we're using our 24 volts in common to replicate the circuit board. And then our last one here, this is our variable speed motors. So on our serial port variable speed motor. So that's going to be like our S9 V2, S8 V2. These furnaces that have a 4-wire plug going to the motor. Simple still, not that complicated. We've only got one speed test to test, but we're still going to check, do we have 120 volts going to our fan motor? Still need to check that every single time. Got to verify, do we have high voltage going to the motor? Sometimes we do, sometimes we don't. Generally speaking, we do. And then we're going to have this 4-wire plug going to the motor. That 4-wire plug, we're going to take off the board and we are going to apply 24 volts in common to it. As you can see here, it wants 24 volts to pin 4. Sorry, it wants common to pin 4 and 24 volts to pin 3. Then you're going to power this thing up. Yeah, I can put the igniter resistance back up there again. We're going to power it up and that motor should run. If the motor does not run, you've got a bad motor. And if the motor does run, you typically speaking have a bad board. One thing about doing this test is we do want to make sure that plug is plugged into the motor. I have seen, it's rare, but we have seen a bad wire harness. And so if you're already going to have to pull the blower to replace it, it would be a good idea to go straight to the motor with those 24 volts. That's it. And that's how we test our motors. They're all go, no go test. Every single one of these pictures I just showed you, these are all in the service packs. I didn't make these. These are all directly out of the service packs or the IOM. Usually it's one of the last pages on these blower motor tests, but they're right in the books. I understand that the service packs don't always stay with the furnace. You know, they're a great knee pad that comes in the box, right? So you're not kneeling on the concrete or wherever this, or in the crawl space. That being said, you can reach out to tech services. We can get you the service packs. We can get you these go, no go tests. More than happy to help you out with that stuff. But it does come with the unit. And so if you're in a spot that has no service, if you're in a spot on the weekend and we're closed, that happens. I know it does. Please understand, you know, it's in the service packs. If you're not sure, I mean, you can dig through those things and you can find this information. I'm not making any of this stuff up. And that was my last one. I had some people asking for some pictures. I want to go back to this one first. If you do have other questions, please throw them out there right now. And we're going to go, I'm going to show the igniter resistance one next. But that's what we have for this simple kind of furnace diagnostics. Those are the most common things we get asked on the tech line. So I just want to make sure we're hitting those key points that we get asked regularly. If you have any other questions, though, please throw it out.